on November 21st, President Vladimir Putin of Russia authorized the launching of a new type of weapon system, an intermediate range ballistic missile called the Oreshnik, which has now been dominating a lot of the news out there. A lot of people, both inside Russia and outside and in the West and in the United States, are all trying to figure out exactly what this weapon is and what it can do. We had Professor Ted Postol from MIT on shortly after I think like right after, the day after, to give us an initial assessment of what these missiles might be like and what their capabilities are, et cetera. And now then in the intervening time, we've had a little bit more time to analyze this. And so we have some new ideas about what this thing may be. And we have Ted back on with us today very graciously to give us an update on what some of this. And we're going to look at this in light of some of the claims that have been made since you were actually on. And we'll examine those in some detail. But first of all, Professor, welcome back to the show as always.
Well, it's a great pleasure to be here as always.
Well, listen, we are always eager to have you on anyway, because you can provide some clarity and at least some knowledge, as opposed to just some opinions that a lot of people are passing without much knowledge, which is a welcome change to the mainstream narrative. But before we get into your presentation, I want to kind of get a running start by showing you what some key people are actually saying about this. First of all, one of the claims that Putin is making is that this is a missile that cannot be intercepted by current technology.
Такому оружию на сегодняшний день не существует. Ракеты атакуют цели со скоростью 10 махов. Это 2,5-3 километра в секунду. Современные, имеющиеся в мире системы противовоздушной обороны и создаваемые американцами системы противоракетной обороны в Европе подобные ракеты не перехватывают. Это исключено. Подчеркну еще раз, что не Россия, а именно США разрушили систему международной безопасности. И, продолжая бороться, цепляться за свою гегемонию, толкают весь мир к глобальному конфликту.
So the first thing he's saying is it can't be shot down. And by the way, it's you guys, not me, that caused this. And then I think to add another layer of seriousness to this, I believe it was the next day, he came out and said that this has this equivalent impact of a strategic, i.e. tactical or nuclear weapon, but with conventional means. Here's what he said.
Ракетная система «Орешник» — это не просто эффективное гиперзвуковое оружие. В силу своей ударной мощи, особенно при массированном групповом применении, да еще и в сочетании с другими высокоточными дальнобойными системами, которые также есть у России, результаты ее использования по объектам противника будут сопоставимы по эффекту, по своему могуществу с оружием стратегического назначения. Хотя по факту система «Орешник» стратегическим оружием не является, во всяком случае, это межконтинентальная баллистическая ракета.
So what Putin is saying in total is that the missile is very effective, it can't be shot down, and it has strategic effects on there. But some Western people in Forbes magazine actually just came out and said, yeah, not really so much. It's, this whole rods from God thing based on how it looks when it's landed. It's not really as bad as what he said. According to Forbes in there, they're saying that it's basically the equivalent destructive power of a 2,000-pound bomb, which is, it's not small, but it's not that big a deal. It's not all that accurate. So really, we don't need to worry about it. So we want to know, what is the truth? Is Putin right? Is Forbes right? Or is the truth somewhere in between as far as you can tell?
Well, there's been a lot of claims made on all sides. But I would say that I have some guesses at the payload capability of the missile, which could be between 6,000 and 9,000 pounds of total throw weight. What throw weight is what the missile can lift and throw onto a trajectory. It is definitely not a boost glide vehicle. By that I mean, it is not the rocket motor that launches it toward the target places the trajectory on a classical ballistic trajectory. I'll show you what those trajectories look like. It's what's called a very lofted trajectory because it has a very steep reentry angle at the target area. And the kinetic energy of the incoming munitions, because they come in so fast, gets converted to heat when they hit the ground, and that heat causes the munition to literally turn into a molten metal and vaporize. And the vapors, of course, expand violently, much like the vapors in a high explosive, and they create an explosion effect. The explosion effect, though, is comparable to the weight of the munition in TNT, given the speed. It might be 1.5 times the weight of the munition, or it might be around 1 times the weight of the munition, depending on the actual speed of impact. But the speed of impact is between 3 and 3.5 kilometers per second. That is to say, between Mach 9 and Mach 11, close to there. And the munition weighs itself between 100 and 150 pounds. So it's like being hit with an explosive that's equivalent to about 100, 150 pounds. The munition probably buries itself into the surface a bit. By a bit, I mean a meter or two. This is not penetrating through a big, deep into the ground. And in the process, of penetrating into the ground a meter or two, and of course becoming vaporized, it produces a crater. And the crater is a little bit larger than what the equivalent TNT on the surface would produce, but the shock wave in the air is a little bit diminished, but still significant. So you have the equivalent of 66. We know there were 66 munitions. We know that for sure. I can show you data for that.
Okay.
And we and each of the munitions delivers 100, 150 pounds of explosive yield comparable to TNT. So the explosive yield of the total payload was between 6,000 and 7,000 and 10,000 pounds of TNT, spread over a significant area, though, because the munitions fell in clusters about roughly 800 meters to a kilometer long. So the munitions fell in a spread, which is not a surprise, since they were released from 6 separate canisters. So we have a very rough picture. The exact details we don't know, but I believe at this point, I could be wrong, and I'll be happy to tell your audience I'm wrong as we get to know more. But I could be wrong, but I believe now that we have a good basic design picture, conceptual design picture of this weapon. And the conceptual design is the details of the conceptual design are not very significant in determining its capabilities, assuming I have not made some significant mistake in evaluating its capabilities. And my guess is I haven't, but we'll just have to see.
And then this is not in a vacuum. I mean, you're actually basing some of these off video evidence, off satellite imagery, and off your knowledgeable about these, right?
We have a lot of evidence. I'll show you a little bit of it.
Okay.
We have debris on the ground. Let me, in fact, Gary, why don't you go to slide 8 exactly? If you look at slide 8, there's some debris on the ground. My best guess at this point is this is the outer shell of one of 6 canisters. I'll show you a diagram later. It's a little bit less than a meter in diameter. And if we go to the next slide, I'll show you to the right is the probable nose, spherical nose of the canister. And of great interest to the left is the propulsion section of the canister. So each of the canisters has a propulsion section. And if we look at the next slide, 10, you can see that there is a large spherical chamber in which gas is being produced by some kind of chemical reaction. The gas is not, it's hot, but it's not super hot like from a rocket motor. And there are orifices in the container, and each of the orifices feed a rocket nozzle. And there's only one nozzle left on this particular thing when it hit the ground, but we can see the nozzle. And if we look at the next picture of this, 11, we have another picture. I don't know if it's probably the same piece of material, but you can see there are two nozzles. One of the nozzles on the upper left has been knocked out of position, it looks like. But the nozzle on the lower left, you can see it's attached to some kind of mechanism, a hydraulic mechanism that would point the nozzle in different directions. So what you have is these 6 nozzles, which are all feeding gas out of them. And by maneuvering the direction of the nozzles, you can maneuver the container that is carrying the submunitions. Now, in the next slide, we have a wild-ass guess of what the canisters and the submunitions look like. It's been said repeatedly that the diameter of the rocket that launches it is 1.8 meters. That's plausible. It's about the diameter of the first stage of an ICBM, which we know it's derived from. We don't know if it's exactly what variation of ICBM stage, but 1.8 meters is a good, reasonable number.
And I've heard many people say from the Russian side, especially, that it's a variant of the RS-26 Russian rocket. Does that match what you understand?
Yeah, it could be. It could be derived from the RS-25 or the RS-27, which are all closely related first stage rocket motors. So we don't know what that motor is. I have assumed that it's about a 25 to 35 ton rocket motor. And it's a single rocket motor, it's a single stage. In other words, it's not a staged rocket. It may be, but I don't think so. Because the first stage of an RS-26 or an RS-27 should be able to achieve the range and speed that we observed in the flight. So given that that's the situation, I think we can, it's probably reasonable that it was a one-stage vehicle.
Okay.
And what I've to the left of the stage, which is a 1.8 meter diameter, I postulated 6 canisters in in 2 tiers. If you look to the right, you can see how they're arranged geometrically and how the submunitions are arranged within each of the canisters.
And by the way, do you know what the submunitions are composed of? If it's an inert thing, what is it? What is the material?
I have no idea, but the material is what I have assumed in this case. The canister that the munitions are made of iron, just because I needed a density in order to get the dimensions of the particular cone-shaped submunitions I show in this diagram.
I see.
So if it's a more dense material, like a tungsten or something, those munitions would be slightly smaller. If it's a less dense material, they would be slightly larger. But it really doesn't matter. What really matters is their mass, because their mass and their velocity really determines the kinetic energy that is imparted by them. They are probably covered with some kind of material that an ablative material that's used for reentry vehicles, just to protect them from very high heating rates. My estimates are that the shock wave in front of the munition when it comes in at about 3.5 kilometers per second is close to 4,000 degrees Celsius. So it's hot, and you wouldn't want to melt or vaporize the metal at the tip. So you would put some kind of specialized material that you use on real warheads of longer range, and you'd cover the warhead tip with that material, just so you don't want it liquefying or vaporizing off. So there's some kind of there would be some kind of modest amount of heat shielding on the submunition. So if we go to the next slide, you can see, if we look at the left slide, the vertical axis on the left slide is the altitude in kilometers. And the horizontal axis is the speed in meters per second or Mach number. So if you look at altitudes between 250 and 50 kilometers altitude, you'll see that the speed is increasing as a function of altitude. Well, it's falling in a vacuum, and there's nothing to slow it up. There's no aerodynamic drag. But all of a sudden, it hits the top of the atmosphere at about 50 kilometers altitude, 40 kilometers, depends on what, and you can see it starts slowing up dramatically. I've chosen two different kinds of what are called ballistic coefficients. The two different vehicles are shown to the right in diagrams. One is basically a slightly different shape and weight than the other, and it just shows you that they hit the ground at different speeds. Exactly how important that is? Well, the higher speed is, of course, gives you more explosive impact, but the explosive impact is comparable in both cases. And if you want to get a sense of the deceleration that's going on, if you look at the right graph, we show the altitude in the vertical axis. We show the altitude versus on the vertical axis, and we see on the horizontal axis we show the deceleration in terms of G's of gravity. So you see, by the time it hits the ground, these things are decelerating at very high rates, between 20 and 25 or even 30 G's of deceleration. The deceleration is very dramatic at the lowest altitudes. So when you look at these things come in, they're really bright. They're heated to very high temperatures. So if we look at slide 18, this is a sequence of slides taken by a high dynamic range video camera. By dynamic range, I mean it doesn't get washed. If it's very bright or very dim, the camera can handle the change in intensity, so the whole thing is not washed out. We'll see some videos where the camera is overwhelmed. And in the upper right corner, I have which cluster of munitions it is. So we see the first three, the row of first three is a cluster of 6 munitions coming in. The next two images, 4 and 5, is 4 is the second cluster, and 5 is a third cluster, and 6 is a fourth cluster, each carrying 6 munitions. We have 3 images, or 2 images of the fourth cluster. That would be 6 and 7. And then the fifth cluster, we have 6 images of that. So that would be 9, 10, and 11, 8, 9, and 10. And figure 9 is a pretty nice figure because it shows you, we get all of the munitions very clearly seen in length.
Yeah.
But these are bright, there's stuff burning off them. And then the sixth cluster. So we see 36 munitions come in. And now, if we want to understand what the trajectory of this missile was, let's go back 2 slides, Gary. Good. You can count to 2, Gary. That's good. So no one escapes, Gary. You know that. So the slide on the left shows is from altitude 0 to 100 kilometers and a downrange distance of 0 to 100 kilometers. And it shows the very steep powered flight of the one-stage rocket, which burns out at about 60 seconds and 70 kilometers altitude at a speed of about 3.6 kilometers per second, or nearly Mach 11. And then we see on the next slide to the right what the trajectory looks like for 2 cases. One where it goes 1,000 kilometers, or the more important case where it goes 800 kilometers, which is the distance between Kapustin Yar and Dnipro. Now, what I show a drawing at the apogee is a rocket stage that is flipped over. It's flipped over, pointing downward. You could do that easily with small rocket motors at the front and back of the rockets, even on the front or back, but usually you might do it front and back. And you just pulse the motors. It's a long time in flight. By this point, the rocket has been coasting for about 6 or 7 minutes. So it's a long time before it gets to apogee. And so you can very slowly tip it over. So the canisters can be pushed just frontward, outward. And the canisters have these rocket motors on, very low thrust rocket motors, and they can make sure that they're in the right orientation and maybe even gain a little velocity, but probably not much. And if there's no velocity gained, by the time they reach an altitude of 200 kilometers, they're already traveling at over Mach 11. Of course, they'll slow up tremendously at a 50-kilometer altitude, and they'll slow up to speeds of maybe Mach 9 or 10 or so. So,
and I'm sorry, Ted, what is the impact speed once it slows down from 50 onward? What is the impact speed to your estimation?
The impact speed is probably impact speed is probably around Mach 10 or so.
Oh, okay, so still quite substantial.
Oh, it's quite fast. It's quite fast. No, it's quite a good impact speed. So the munition is a ballistic munition. It's a ballistic missile. Hypersonic is because people have learned the term hypersonic, which simply means its speed is above 5 kilometers per second, and Mach 5, and other than that, it's a ballistic missile that's going at around Mach 5.
So what can you tell us about the impact once they see it? Because one of the big things Putin said, whereas this is going to have strategic impact, almost as though it was like a tactical nuclear weapon, but without all of the side effects or so. But from some of the pictures we've seen of the impact side, it doesn't seem to be that big. So what is your estimate of the impact on the target itself?
Well, I think the impact energy is equivalent to 100 or 150 pounds, maybe 200 pounds, depending on the impact speed of TNT. If we look at slide 20, we can see a sequence of 5 photographs. This is taken with a closed circuit TV that is overwhelmed. It has a low dynamic range. So this is the bright, large images are due to the poor dynamic range of the particular camera. So what I've done is made a wild guess about roughly where the munitions are within these clouds of brightness. And there's 6 images in this particular case. And as we see them go to ground, if you look at the 5th and 6th images, you can see bright spots on the horizon where they impacted, but they're not enormously bright spots. And if we look at the next slide, we can see that if we look at the slide number 6 in this case, we see evidence. Slide 5, if you look to the left, slide 5, the middle slide on the second row, you can see the leading munition is just about impacting the ground. And then immediately next, you see a very bright luminosity. My guess is that is a significant ground explosion caused by something detonating. In other words, this munition hit something that then detonated. Could be, a rocket motor that's in production. And these fell inside a facility where rocket motors were being manufactured.
I wonder if you can answer. One of our guests is asked a question here, which is similar to one that I wondered as well. And they say, and in fact, does it even have the capacity? Those are inert warheads you talked about, but can they launch explosive power if they have different kind of warheads?
Well, if you made the munitions out of high explosives, which would be hard to do because the density, you want to keep these things very dense. And in order to make them very dense, you have to give them slender bodies, and they have to have a high weight in a slender body. So putting high explosives in them could be difficult in terms of the packaging. I haven't studied that in detail, but my intuition tells me you'd have to work at it. You could probably do it, but the best you could do is maybe double the explosive power, because half of the power, if you had equivalent weight of TNT and the kinetic energy of equal to TNT, you get double the energy. So you'd have a 200 or 300 pound explosive in effect.
So would it be fair to say that if you wanted the explosive effect on the target, that a different missile might be like the Kinzhal, for example, which I understand does have explosive payloads? Yeah,
but the Kinzhal has a significant explosive payload, and it hits the ground at maybe 2 or 3 kilometers per second. And if it slows up enough, which it might do, it can penetrate into the ground. You want to penetrate into the ground. In order to penetrate into the ground, you want to hit the ground slowly enough that you don't crush up the munition. Let's go to slide 30, if we can. There's a lot of confusion about this, so I put this slide together. There we are. Now, if you look at the left, what I've postulated is a sub-hypersonic impact. And the outer arrow on the left, there are 2 arrows. The outermost arrow shows you the speed of sound in this submunition, which is about Mach 5. In other words, it's just at the hypersonic limit. Now, if the submunition comes in at a speed of Mach 3, which is what I postulate here, then when it hits the surface, the pressure from hitting the surface can be transmitted through the body of the vehicle, so it doesn't crush up. In other words, it doesn't come in so fast that it crushes up. to the right, I show a hypersonic impact, where the submunition speed is shown to be much larger. And in that case, the speed of sound in the object does not allow the energy, the compression, to be passed through the whole body of the vehicle. So what it does is it crushes up into a small section of the vehicle, and this small section gets extremely hot, like when you compress a gas very, very violently. And because it gets very hot, it becomes vaporized. And then it just, as a vapor, it explodes like a vapor would. It just disassembles. So for example, if you go to the next slide, just one more slide, please. We see what it actually looks like. There's a contact compression where the projectile just compresses up and becomes extremely hot. The compression results, if you look at the figure to the right, first row to the right, you get a vapor produced because the temperature is driven to very high temperatures by the high speed getting converted, the kinetic energy of the high speed getting concentrated into a small volume of material, raising it to a very high temperature, 4,000, 5,000, 6,000 degrees Kelvin or Celsius. That material violently expands. It's a vapor. And then in the end, you get a crater. And the crater looks like craters on the moon or craters on the Earth or craters from bombs that detonate as they hit the surface. Now, you can get a bigger crater with the bomb at the surface if you slow the bomb up so it hits the ground, let's say at Mach 3 rather than Mach 5, Mach 3 like I showed you in the earlier diagram. Then the bomb can survive the impact as a unitary munition, and it will have enough momentum to penetrate into the ground, sometimes 3 or 5 or 6 meters. That depends on the ground, or if it's penetrating concrete, a shorter distance, depending on the concrete.
So
when you detonate that, it makes a tremendous, because all of the munitions is now inside the material in which it's detonating, and it creates a devastating effect in the ground. Or if it's in a chamber.
That's a perfect segue. It creates a devastating effect. So the question is, Putin claimed in that clip I showed earlier that this has strategic effects, that it has devastating consequences on the ground. But I know that you've looked at some of the satellite imageries we've seen, and do you see corresponding significant destruction, or is he exaggerating? How do you view that from what you've seen?
I don't know if he's my view of Putin. This runs against my view of Putin. What he's saying is not. I don't even like to say it's not correct. It's not. He's saying it in a way that I do not understand. Okay, which now the reason I'm so cautious about the way I say this is because I do not think Putin is a guy who makes false statements about things like this, because he has adversaries, and he doesn't want to be caught misrepresenting something or making a mistake on something this basic. So whatever he's saying is different from what I understand, but I'm not sure it's different from what he understands. This kind of thing may be the result of miscommunication from overly enthusiastic technical people who have given him words to say, and who do not appreciate the political way that these words could backfire. And he may have been misinformed. I had an experience like this. I got in trouble with George H.W. Bush because I was reporting that the Patriot basically intercepted no warheads in the Gulf War of 1991. And President Bush, quite honestly, He did not lie. He went to Raytheon and he said they intercepted 45 of 47 Scuds. He was told that, as was incidentally Dick Cheney, the then Secretary of Defense, were both told that. And neither of them knew what actually happened until Moshe Aarons, who was the Minister of Defense in Israel, met with them in the White House in February and said, no, it's not true.
Wow.
So you can imagine how pissed these
Yeah.
guys were because, and I heard rumors that Cheney was out there looking for me. I don't
That's
know what
never
I
a good
did.
thing.
All I did was tell. But
He's Ted. He's still looking for you, by the way.
Yeah. By the way, yeah, just
might be.
be careful.
I saw what he did with those people. He was hunting birds. So
Yeah, exactly. Those were his friends, but just imagine.
Right. So
Can you show us with your presentation here what you have seen about the impacts that it had on the ground?
well, if we look at slide 36, we have an example of ground damage. Supposedly, we have tried very hard. My colleague Chris Kabusk and I, Chris is very, very good at geolocation. He's really skilled at this, and so he came in and offered his help. It was very generous of him. So this is a structure we believe was hit on November 21. It does not look to me or to Chris like it was hit with one of these submunitions. I don't know what did all this damage. One possibility is that a rocket stage or some large piece of the rocket, which slowed up substantially, was not at supersonic speed, just fell through the roof of this.
And do you make that comment because the damage is not enough from what you would have expected with one of the
well, you'd
submunitions?
expect possibly the walls would be blown out. You should have enough overpressure from the equivalent of 100 or 150 pounds of explosives going off inside this building to knock down the walls. I mean, that's what I would guess would be in effect. You notice that the windows are blown out. So whatever went in blew out, moved the air violently enough that it caused enough internal pressure to blow the windows out. But that only takes a couple of pounds per square inch of pressure. But to get 10 or 15 pounds per square inch of pressure to blow the walls out, you need something more energetic output. So that's one image of damage. The next slide shows you another image of damage. Something hit the upper part of this building. It looks like it shattered the upper walls of the building. It probably hit something substantial, maybe a concrete floor, and vaporized on the floor. So this may have been a submunition that caused significant damage, had a chance to vaporize somewhere in the upper structure, did not penetrate through the structure because it was traveling so fast. When it hit a concrete surface, it just vaporized.
Wow.
And created an explosion. That's my guess. I want to underscore these are guesses. We have not been able to find very significant images of damage. In the next image, we see a fire that was initiated by something that hit near this building. That is certainly a plausible result of one of these munitions hitting near the building, because the vapors would be very hot. They would, of course, cause a shock wave. But if they were close enough to something that was combustible, they could set things on fire. And that's what looks like it possibly happened here. In the next image, it's not even clear what happened here. I can't even be sure that we're seeing damage of any kind. This is supposedly damage of some kind. Maybe there was something that got hit further away behind this man who's cleaning up something, but it's not clear what we're seeing. If we look at the next image, it looks like some things hit the ground and set fire. They didn't leave large explosive craters, but they set fire to shrubbery or something, and that could have been submunitions. But if I then go to the next 2 slides, there's pictures of general damage inside buildings and at buildings, but there's nothing leveled.
Yeah.
And, 500-pound bomb, if it hit one of these buildings, would level it. You would see a flat building. And if you look at damage in Dnipro from earlier attacks prior to November 21, where the attacks were with cruise missiles, Iskanders, and things like that, you see significant craters and you see flattened buildings. You don't see that in this particular case. We're just unable to see it. So if I'm wrong, first of all, anyone in the audience who thinks they have found damage from November 21, please send me information. I'm extremely interested in this. What I've found so far is consistent with the phenomenology that I would expect. So I'm not surprised by this. There's nothing happened here that defies my physical grasp of what I think is going on or has gone on. But I could be wrong.
So if I can tell me if my summary is correct. So these missiles, we can't intercept them.
We can't intercept them, right?
Okay. Secondly, so the inert warheads that come in did not have explosive power, so they can cause damage on the ground. And as you showed in that one, if it hits something,
they have explosive power. There's like 100-pound munition coming through your roof, and
so it's not gonna like wipe out something. At least it didn't in this particular.
Not from what we can tell.
But then the biggest question is, if the warhead is changed to a nuclear one, how would that be different?
All bets are off. The vehicle could certainly carry 5, 6, 7, 8 nuclear weapons. In other words, those canisters could be replaced by what's called a boost, just warheads. But probably you'd build what's called a bus, a vehicle that has a little bit maneuver capability and has several warheads placed on it. And instead of building these separate canisters, you might build a single canister that's got a 1.8 meter diameter, and you'd mount, 6 warheads on it. The warheads would be bigger. The bus would be bigger, and the propulsion system would be somewhat more. It'd be about the same, very low pressure rocket motors, not very powerful, just enough to move the warheads around.
And would these warheads would they be ground burst or would they air burst? And what's the difference?
They could do either. And they could be. Let's see, if you have, they could easily be half megaton each, 5 or 6 half megaton warheads. That would, just turn a very large area into devastate a very large area. Would set fires over ranges of 4, 5, 6 miles, 7 miles. In other words, you'd cause a mass fire from the fireball brightness over 150 square kilometers or 200 square kilometers.
So then that would
set the whole place on fire.
That wouldn't be a tactical nuke. That would be a strategic nuke. Is that correct?
Well, it's tactical depending on its range and target. I don't think the Russians don't make all these sharp discriminations between tactical and strategic, because tactical is probably on their soil. tactical is on someone else's soil for Americans, but not for them necessarily.
And Gary,
And-
could you show that video that has that shows the ranges in time and how long it would take this missile to arrive at different locations? This is what's being reported. Does this seem to be reasonable to you about how long the time of flight is to get to various targets?
Yeah, that's reasonable because you'd be using normal trajectory. You wouldn't be lofting the trajectory, so you wouldn't have to spend all that time. No. Yeah.
So some are quite short.
15, the time is short, so it's correct, but it's not. I wouldn't call it new. In other words, Russia already has this capacity in existing missiles, this nuclear capacity. So, is it a new system? Yes. Are there systems that can do similar missions? Yes. Is that important? I don't know. It depends on what, how you think about these things. But certainly, this is a capability that Russia now has right this minute, which is something we ought to be thinking about.
It should definitely factor.
So when we provoke the Russians unnecessarily, and somebody says, "Oh, don't worry about it. It's only nuclear weapons." I mean, they're delusionary. They have no idea what they're talking about.
They do, and let's hope that
I hope people who have those ideas go back and look at the discussion we had about the effects of nuclear weapons.
Right.
That's one of the reasons why we all agreed it was important to discuss that. These are not just big TNT. They are different. They create a fireball that's hotter than the surface of the sun when it reaches its maximum size, which is typically fractions of a mile in diameter. That fireball sets fires at many miles range. The fires set a vast area on fire simultaneously, causing firestorms where the ground winds are hurricane force because it's like being inside a gigantic fire, and the air temperatures are well above the boiling point of water. Nobody lives through that. This is Hamburg on a scale like we've never seen before, and or Dresden. So, and that's just one of these weapons. So we don't want to be in a situation where they're used in any significant numbers, in any numbers.
Any numbers. Yeah, absolutely. Right. We certainly do. Well, listen, we really appreciate it. This has been absolutely fascinating. Really appreciate you coming on and doing all the work. And by the way, people, this is a tremendous amount of work. We're even onto the shoulders of Professor Postol. We're very, very grateful and our audience is very grateful for this. So thank you so much.
Well, you've really pissed off my wife. Let me tell you that. That's a bad thing to do.
We'll be a little.
I'm not so afraid of the U.S. government, but really, I'm afraid of her.
Yeah, well, we don't want to do that, especially so close to Christmas.
Right.
So,
right, absolutely.
All right. Well, thank you very much for coming on, and we appreciate you guys coming on. Also, to let you know, we're going to have Alexander Mercurius on this afternoon. I believe it's 3 p.m. Eastern time today. Going to look at what's going on in Ukraine. There's some very strange thing where Ukraine is giving an ultimatum to NATO. What is that all about? And what is Keir Starmer saying? How does that make any sense? Some of the comments coming out. You will not want to miss that. Alexander Mercurius this afternoon, 3 p.m. on Daniel Davis Deep Dive. Thank you very much, and we will see you then this afternoon.